So some rules are regarding that. First is Stephen's law. What is Stephen's law? The source of heat energy, what heat energy they are radiating per second from per unit area, heat energy radiated from a source from unit area per second is directly proportional to fourth power of absolute temperature. Is directly proportional to fourth power of absolute temperature. Heat energy, unit of any energy is joule. I am telling you what is E, unit of E in this place. It is heat energy radiated per second, means second should be in denominator, from unit area, and you know that joule upon second is watt. So E is watt per meter square. Next thing, when you are removing this E, we are getting one constant. It is denoted by sigma, known as Stephen's constant. Since we are not taking the temperature of surrounding in account, Boltzmann make a little correction in this. He make a correction that temperature of surrounding should be taken in account. So he make this law like this. E should be proportional to T raised to the power 4 minus T1 raised to the power 4, where T1 is the temperature of surrounding. Temperature of surrounding. Constant is same, so that's why we can say this constant Stephen-Boltzmann constant also. And this law is known as Stephen-Boltzmann law. He didn't remove the name of Stephen. He put his name first. So this law is known as Stephen-Boltzmann law. But if they are not talking about the atmospheric temperature or temperature of surrounding, you have to use this first relation for numerical. They can say, if from unit area per second 10 calorie heat energy is, source is radiating 10 calorie per second from per unit area, and its temperature was 27 degrees centigrade. If I make it 527 degrees centigrade, what should be the, initially it is radiating, suppose 10 calories per second per unit area at 27 degrees centigrade. What heat energy it will radiate at 527 degrees Celsius? How to solve? Remember, we are using for temperature capital T. It means temperature should be in Kelvin. Temperature should be in Kelvin. So, convert this in Kelvin by adding 273. So, you will get for this 300 Kelvin. Note down, for Kelvin we are not writing degree. Add 273 in this. What we are getting? Or make is 627. Make it 627. You will get 6 and 2 8 and 1 900 Kelvin. It means you make the temperature thrice, but E is proportional to T raised to the power 4. If temperature is tripled and 3 raised to the power 4 is 81. It means heat energy per second from unit area should be now 81 times. If initially it was 10, so now it should be 10 into 81, 810 calories per second per square meter. So this type of questions they can ask in exams. They are not time consuming. If you know the fact, within time you can solve that. Oral you can solve that. So adverse you have to learn Stephen's law. Next, so many times they are discussing about one more law is there, Wien's law of displacement. What is Wien's law? Ki wavelength, we know that what is energy? Energy is hc by lambda. Hc by lambda. Lambda is wavelength. It means with each energy one wavelength is associated. So wavelength associated with maximum energy lambda m, and temperature of source at that time, this product is always constant, and this constant is known as Wien's constant. So it should be constant. Ki wavelength are related to maximum energy and temperature at that time, their product is always constant. It is Wien's law. And next important law on which they can ask problems is Newton's law of cooling. What is Newton's law of cooling? Ki rate of cooling, suppose an object is cooling and its temperature is down from theta 1 to theta 2 in a t second. So what is Newton's law of cooling? Rate of cooling is directly proportional to mean temperature minus temperature of surrounding. If surroundings temperature is low, only then cooling will take place. So if that at surroundings temperature was theta and an object's temperature down from theta 1 to theta 2 in t second, so rate of cooling is directly proportional to temperature difference of mean temperature of object and temperature of atmosphere. So getting my point? So this is again very important rule. It means if surroundings temperature is 30 degree and object's temperature is 60 degree, so when it will cool down means 60 to 50, 50 to 40, 40 to 30. When the temperature is downing, it means this term is decreasing. If this term will decrease, rate of cooling will decrease. It means when one object is in the process of cooling, so the rate of cooling will increase. That's why they are saying, if you are waiting for your friend for a tea, tea is hot, okay, your friend is not there, and you want to serve him hot coffee or hot tea, don't mix sugar before coming of that person, or mixing the sugar before coming of that person. What should you do? Ki we should mix sugar with that hot tea before coming of that person, or we should mix after coming of that. What should be your answer? Mix the sugar before coming of that. Why? It will down the temperature. Sugar will absorb some heat if you mix now or after coming of your friend. But if you are mixing now, temperature is little bit low now, so now rate of cooling will become slow. Otherwise, fast it will become cool. rate of cooling will be fast. Okay, so this type conceptual problem they can ask in your exam. So it was all about which we have to learn from this chapter. We will get so many questions on these. Next, we are moving towards elasticity. It is again very important topic of properties of bulk matter. What is elasticity? We divided whole objects in 3 categories: elastic, plastic and rigid. So there are 3 types of elasticity, 3 types of materials which are present at our planet. Either they are elastic, or they are plastic, or they are rigid. What is difference between these 3 categories? If you want to deform some object and you are applying a force on that object, so if after removing your force that object is coming in original shape or size, you can say it is elastic. But if change is permanent, you can say object is plastic. But if there is no effect of your force, means after applying force, you are unable to change the shape or size, it means that object belongs to which category? Rigid bodies. What is perfectly? No object is perfect. So most elastic object is quartz. Most plastic object material is china clay, and most rigid body is glass. Students sometimes are confusing with diamond. Diamond is most hard object, not most rigid. Hardness of diamond is too much, but rigidness of glass is maximum. It will break, but you cannot change the shape or size of glass object. So these were for theoretical purpose. And in elasticity, again there are 3 types of elasticity. Elasticity are related with length, elasticity are related with volume, elasticity related with shape, because your deforming force can do 3 things. It can change length, it can change volume, it can change shape. If there is a change in shape, coefficient of elasticity is known as coefficient of rigidity, denoted by n or eta. N or eta. When change in shape, it is coefficient of, I will tell you what is coefficient of elasticity. If there is a change in length, coefficient is Young's modulus, denoted by y or gamma. If change is in volume, coefficient of elasticity is known as bulk modulus, denoted by k or beta. This is again important because reciprocal of bulk modulus is known as compressibility. Compressibility and for gases, again there are 2 types of volume elasticity. One is at constant temperature, denoted by E theta, known as isothermal elasticity. Another one is E phi, when temperature is non-constant, denoted by E phi, known as adiabatic elasticity. Isothermal elasticity is equal to initial pressure of gas, and it is gamma times the initial pressure. Gamma is ratio of two specific heats, which you can calculate by 1 plus 2 by n, where n is degree of freedom. It is degree of freedom. So now we are moving towards what is coefficient of elasticity. When suppose I have this one wire and I want to increase the length of the wire, I am applying a force F and its length is changed from L to L plus delta L. Area of cross section was A. If this wire is elastic, after removing my force it will go back, length will again become L. It means when I applied one force, there was equal and opposite internal reaction in the wire, and that reaction wants to take this wire back within a limit. It is equal to my applied force. When I will remove my force, it will go back, but after a certain limit, change will be permanent. That limit is known as elastic limit. So within elastic limit, that internal reaction is equal to your applied force, and that internal reaction per unit area is known as stress. When length is increasing, this stress is known as longitudinal stress. It is, in this case, when we are talking about length. When change in volume, it is normal stress. When there is a change in shape, it is tangential stress. This, it means force per unit area. Force per unit area is stress, and change in dimension, whatever it is it volume, is it shape, or it is length, change in dimension upon original dimension is known as strain. Just like stress, again strain is of three types: longitudinal, normal, or tangential, or you can say this, one more name is there, shearing or shearing, tangential or shearing. So strain is also of three type. Young gave one rule that within elastic limit for this longitudinal stress, stress is directly proportional to strain, but it is valid for all. And we are removing this, we are getting one constant, that is coefficient of elasticity. When we are discussing about this length, what we are seeing, when you are stretching the wire, it means you are spending your energy after removing your force. That energy is used to take back to the wire, It means that stored energy we can calculate by the formula. You know this, half stress into strain into volume. If you apply stress, there is a strain, it means energy is stored in your wire. You can calculate this by half stress strain into volume. If they are talking about energy per unit volume, put in place of volume 1. Getting my point? One more thing will happen. If you are stretching a wire, it will become thin. It means its diameter is reducing. Diameter is also one kind of length. It means in perpendicular direction, length is reducing. So, one strain is there also. That strain is known as lateral strain. Lateral strain. And the ratio of lateral strain to longitudinal strain is known as Poisson's ratio. It is known as Poisson's ratio. Once they asked in competitive exam, its theoretical limit. Theoretical limit are from -1 to +half, and practical limits are 0 to half. For different material, it will vary from theoretically -1 to half and practically 0 to half. So, if you are discussing about Young's modulus, your applied force is equal to, within elastic limit, internal reaction. So, you can use your applied force, which is generally in form of weight, as internal reaction. So, you will get this formula. If bulk modulus is there, stress means pressure, pressure is also force per unit area, into original volume upon change in volume, and compressibility is its reciprocal. And for eta, remember always, shearing strain is always in terms of angle. We are measuring shearing strains in terms of angle. Now, we will discuss little bit about viscosity and surface tension. What is surface tension? Surface tension arises due to intermolecular attraction. We know that molecules of same nature are attracting each other, and molecules of different type, they are also attracting each other. Force of attraction between same type of molecule is known as, we will discuss now two things. So, we are bifurcating this in this two part. First is surface tension here, and we will discuss little bit formula for viscosity here. It is surface tension. We will discuss in this part. We will only discuss a little bit which is important for you. First thing, remember, force of attraction between same type of molecule is known as cohesive force, and different type of molecules is known as adhesive force. Cohesive, same type; adhesive, different type. If we imagine one imaginary line on a free surface of a liquid, it will divide whole liquid into two parts. So molecules on this side will attract the molecule on this side. So one force is acting on this complete line. If we calculate this force for unit length, it is surface tension. So its dimensional formula is mt minus 2 and unit is Newton per meter. Getting my point? So it is the dimensional formula and it is the unit. Newton per meter. One liquid will wet the solid or not. It depends on angle of contact between that liquid and solid. If you are putting a liquid in a solid, three things will happen. Either shape of free surface will be plane, or it is of convex type shape, or it is of type concave type. At the point of contact, if you draw two lines, one is touching the liquid, one is touching the solid. Angle between them, which is inside the liquid, is known as angle of contact. Angle of contact. It will decide that this liquid will wet this surface or not. In this case, it is acute, in this case, it is obtuse, and in this case, it is 90 degree. It is greater than 90 degree. Theta is equals to 90 degree. Theta is greater than 90 degree. Theta is less than 90 degree. Example, if you learn example, you can tell it is example of glass and water. It is example of glass and mercury, and it is the example of silver and alcohol. So you know that water wet the glass. If on a glass surface you will put water and make this surface like this, all water, maximum water will fall down. But if you touch your finger to glass surface, you will find some water molecules are present there. But if you put mercury on one glass surface, do this surface like this, mercury will fall down. Now if you touch the glass surface, no mercury is there. So you can learn by this. If angle of contact is obtuse angle, then that liquid cannot wet that surface. If for a liquid solid pair, angle of contact is acute angle, that liquid will wet that surface, because in that case cohesive forces are less than adhesive forces. In this case, adhesive forces are less than cohesive forces. In this case, they are equal. So now one more important factor is there. If you are increasing the free surface area, you have to do work, and that work you can calculate work or change in energy by the formula surface tension into change in area. They will give you numerical on this. Okay, if you are willing to increase the free surface of a liquid, what you have to do? See, in this glass, free surface area is less. If you put this liquid in this beaker, what will happen? You are increasing the free surface. It means some molecules from downside, it will come on upside. But molecules were attracted by the molecules which were nearby that molecule. If it is going up, that attraction between two molecules will oppose. You have to work against that force. It means you have to spend your energy. It is stored in this form of potential energy. And that energy we can calculate by the formula surface tension into change in area. See, if I have a U-type structure of 3 wires, I put it in glass in a liquid and slowly I take it out, suppose in soap solution. And fourth, I have this type of, see, I have a structure of made up of 3 wires, this, and this fourth movable wire I keep it here. Gently I dip it into soap solution, take it out. If slowly I am moving this wire, it means I am increasing the free surface. But in this type of example, when you are increasing the free surface area of a film, it is not liquid free surface, it is a film, then 2 surfaces are increasing, one upside and one downside. Then if you want to calculate delta E, you have to use the formula ST into 2 delta A. But in case of liquid, in this example, we have to use formula for this. If it is this film, you have to use this formula. Again, due to shape, in a liquid drop, there is excess pressure, and that excess pressure, you can calculate by 2T by R. Because liquid has one free surface, if we are talking about soap bubble has 2 free surface. So excess pressure in soap bubble we can calculate by 4T by R. So remember these 2-3 things. These are sufficient for your competitive exam and your revision. Now we are going to discuss about viscosity. What is viscosity? Again, due to intermolecular attraction, there is a resistance between the flow of liquid layers. If one layer is going away from another layer, it will oppose due to that intermolecular attraction. This resistive force is known as viscous force, and it is directly proportional to velocity gradient, means change in velocity per unit distance. It is directly proportional to area in contact. If you are removing this, you will get one constant which is known as coefficient of viscosity, If you drop a solid ball of radius r, density rho in a fluid, it will disturb the fluid layers, and fluid will oppose the motion of this ball, and that force you can calculate by Stokes' law, and it is 6 pi eta a v. It means if you drop a metallic ball of radius a in a liquid, it will oppose the motion. Liquid will oppose the motion of ball inside the liquid, and it will put a force which should be equal to 6 pi eta av. But drop is coming down due to its weight in that liquid, which you already studied in 9th class, Archimedes principle, that you know that if density of liquid is sigma, the weight inside the liquid of this drop, it should be weight in air, and we are writing weight in terms of volume into density. What is volume? 4 upon 3 pi, radius is r, r cube, radius is r, so we have to write here r. If we are taking radius r, it should be r. 4 upon 3 pi r cube volume into density into g. But when this metallic ball will go in liquid, it will displace same volume of liquid, and there is a change in weight which should be equal to, upthrust should be equal to the weight of displaced liquid. It is liquid's density. So inside the liquid, weight of this drop or this metallic ball will become this. It is coming down due to this weight, and due to this force, its velocity is continuously increasing. It means opposing force is also increasing. If at some point both are equal, what will happen? Now net force will become 0. Net force will become 0. It means no acceleration there. Now velocity will become constant. This velocity is known as terminal velocity. Cancel 1 r and you can see that your terminal velocity is directly proportional to radius square. So this is one important result you have to remember. If liquid is flowing in a pipe, rate of flow of liquid, you know that liquid is flowing due to pressure difference. So rate of flow of liquid you can calculate by the formula. It is known as Poiseuille's formula, pi p r4 upon 8 eta L. What is it? A rate of flow of a liquid in a pipe. P is pressure difference, R is radius, eta is coefficient of viscosity, and L is length of pipe. Also you can compare this with Ohm's law. Their rate of flow of charge, it is the cause. So you can calculate resistance. What should be resistance? What should be the value of resistance? It should be equal to cos means potential difference divided by resistance. So it should be 8 eta L upon pi r raised to the power 4. So these were some important points. Detail we have discussed in the theory classes, which you have already slides in complete syllabus of NEET. I was giving you some tips for crash course. Now we will discuss the crash course problems. Thank you.